in Maharashtra, India, is one of the driest regions in the state and serves as a prominent example of how land degradation can worsen water scarcity. Situated in a semi-arid region, Latur has been grappling with severe water shortages for decades. Declining soil moisture retention ability, along with the over-extraction of groundwater resources, is the main reason for these challenges. This situation has heightened stress among farmers, increased energy use, and raised the costs of cultivation. It has also caused widespread migration from the region. To address these challenges, the International Crops Research Institute for the Semi-Arid Tropics, with the support of the Groundwater Survey and Development Agency of the Government of Maharashtra, has been developing a learning site in Matephal village, covering an area of 1,220 hectares. This initiative has been underway since May 2023 under the Atal Bhujal Yojana. Under this initiative, landscape resource conservation measures are integrated with field-scale climate-resilient technologies following water balance. Based on soil type and land slope, larger fields are divided into smaller plots through field bunding, along with field drainage masonry structures. 6 farm ponds with storage capacities ranging from 1,000 cubic meters to 8,000 cubic meters were excavated on farmers' fields, and about 8 kilometers of the stream were widened and deepened, along with suitable nala plugs starting from the ridge areas. These interventions created a total of about 110,000 cubic meters of water storage capacity, covering approximately 700 hectares of the landscape. The combination of in-situ and ex-situ interventions allowed for the harvesting of an additional 350,000 cubic meters of runoff water during the 2024 season. This has significantly improved soil moisture in 500 hectares. As a result of these interventions, groundwater availability increased by almost 4 meters when compared to the nearby control sites. Advanced monitoring tools such as automatic weather stations, gauging stations, time domain reflectometry, and diverse sensors were installed to track meteorological data, surface runoff, soil moisture changes, and groundwater dynamics. The data gathered from these advanced tools is used to understand village-wise and crop-specific water budgets. As much as 10 hectares of permanent fallow land and 50 hectares of seasonal fallow land were brought under cultivation, enabling double cropping. Crop yields increased by 30% during the Kharif season, with similar improvements expected during the Rabi season, corresponding to an additional income of rupees 4 crores. The initiatives in Matephal village not only enhance agricultural productivity, but also contribute significantly to increasing local fisheries and livestock production. A total of 20,000 fingerlings were released into 2 farm ponds. These fingerlings resulted in the production of approximately 30 tons of fish. The fish produced in these ponds have an average market value of rupees 40 lakhs. With improved water availability from the farm ponds and enhanced fodder resources, farmers have been able to increase their livestock population, and milk yield has risen by a minimum of 1 liter per animal. The integration of soil and water conservation practices has not only enhanced agricultural productivity, but also improved key ecosystem services. The initiative in Matephal village illustrates how sustainable agricultural practices, focused on water and soil conservation in a decentralized manner, can simultaneously protect the environment, enhance biodiversity, and improve the resilience and livelihoods of farming communities, particularly in the face of climate change.